We'll be going through the applications of integration in this topic. So before we start, let's recap on integration techniques that we've learned previously. Firstly, our basic techniques. If we integrate a constant, so this k represents a constant, you simply add an x behind, and remember, every time you integrate something, you have to add a plus c behind. And then if you integrate x to the power of n, you'll basically do x to the power of n plus 1 over n plus 1, which is your new power, then plus c. For reverse chain rule, integration of ax plus b whole thing to the power of n is just basically adding 1 to your power, then over your new power, n a, multiplied by a, and then plus c. So you use reverse chain rule only when n is not equals to negative 1. Next, integrating trigo. So the integration of sine is always negative cosine. Do not forget the negative sign. And then if inside the brackets is ax plus b, then you have to multiply it by a 1 over a in front. The integration of cosine is simply sine. And once again, if it's ax plus b, you have to add a 1 over a in front. The integration of secant square is tangent. Next, advanced trigo. So when the question asks you to integrate sine square x or cosine square x, you cannot use reverse chain rule on trigo. You have to use the double angle formula of cosine 2x. After using the double angle formula, you can make either cosine square x or sine square x the subject, which leaves you with these two expressions which you can then integrate, instead of integrating cosine square x and sine square x directly. And then to integrate tangent square x, you have to use the trigo identity. 1 plus tangent square x equals to secant square x. Then you make tangent square x a subject, and you get secant square x minus 1. Therefore, instead of integrating tangent square x directly, you will integrate secant square x minus 1 instead. Next, exponential. Integrating e to the power of x will just give you e to the power of x again plus c. But then when you integrate e to the power of ax plus b, you have to multiply it by 1 over a in front. Next, for ln, integrating 1 over x will give you ln x. Now this is when the power of your x is negative 1. So when you see this, do not fall into a trap of using reverse chain rule, because if you remember, you only use reverse chain rule when n does not equals to negative 1. In that case, you'll be using logarithm instead. Finally, integrating 1 over ax plus b will just give you ln ax plus b, so these are the same, and then multiplying it by 1 over a in front. Now moving on to our integration application concepts. Firstly, using integration as a reverse of differentiation. We cannot integrate a quotient or product in integration, so we have to make use of integration being the reverse of differentiation. Now this is also known as the Mr. A, Mr. B technique. Since the differentiated of Mr. A gives you Mr. B, doing the reverse, so integrating Mr. B will give you Mr. A. For example, if you differentiate 4x squared, it will give you 8x. Therefore, when you integrate 8x, it will give you 8x squared over 2 plus c, which is 4x squared plus c. So 4x squared is your Mr. A, and your 8x is your Mr. B. In this kind of questions, the question will usually tell you to differentiate first before finding the integral. So finding the integral will also be known as a hence question, a part B question. When we find the integral, we cannot start with the question. We need to manipulate our part A answer. Now we can see this better in the next few examples. Differentiate square root of 5x squared plus 3 with respect to x. Hence, find the integral. Okay, let's do the differentiation first. We can re-express this, the square root, into power of half. So differentiate it, you'll bring down the power, and then reduce the power by 1, and multiply it by the differentiator of inside the bracket. This is your usual differentiation. And then you will get 5x over square root of 5x squared plus 3. So this is where your Mr. A, Mr. B method comes in. Your Mr. A will be what you have differentiated from the question. And your Mr. B will be the final answer that you got, your differentiated answer. Firstly, when you look at the integral they gave you, there's no way you can directly integrate it because we can't use any type of quotient rule in integration. And secondly, it is very similar to your Mr. B. So this is when you know that the question is telling you to use the Mr. B, Mr. A method. By solving this question, we will have to start with the integration of Mr. B equals to Mr. A. So integrating the answer that we have, we know that we'll end up with what the question wanted us to differentiate in the first place. Then we want to manipulate our Mr. B, so this one over here, into the integral that we need from the question. How do we manipulate it? We need to get rid of the 5 in the numerator, right? So we can multiply both sides by 1 over 5. Doing that, we'll be able to remove the 5 from the numerator because these two will cancel out. Then doing the same on the other side, 1 over 5, 5x squared plus 3 plus c. Now that this has been cancelled away, we can see that we have manipulated it into our integral that we need, therefore getting our final answer. And that's how we use the Mr. B, Mr. A method. This is quite an important concept to know, and it might get a bit confusing, so we'll do a few more questions. A curve has the equation y equals to x minus 1 square root 2x plus 1. Part 1. Show that dy dx equals to that, where k is a constant and state the value of k. So once again, the first part of the question is always asking you to differentiate something. So we just do our normal differentiation using our product rule. And if you all forgot how to use your product rule, you'll just keep the first bracket and differentiate the second bracket. So bring down half and then reduce the power by 1, so negative half. And then multiply by the differentiation of inside the bracket. Then you will do the opposite. So differentiate the first bracket and then which just gives you 1, and then keep your second bracket. So eventually, once you simplify your equation, you'll end up with something like this. And from here, you can factorize the smaller power. So you'll see that the smaller power between these two will be negative half, because you have negative half and half. Obviously, negative half is smaller. So you factorize out the smaller power, and you'll be left with x minus 1 and 2x plus 1. How do you get 2x plus 1? Factorizing out basically means dividing, right? So 2x plus 1, you factorize out 2x plus 1 to the power of negative half. So you will divide by negative half. Now if you remember your indices, dividing also means subtracting the powers. So 2x plus 1, half minus half, which will give you 2x plus 1 to the power of 1, and it's just 2x plus 1. That's how you arrive here. Then you simplify within the square bracket and you will just get 3x. Afterwards, you bring the negative power to the denominator. This is the negative power, so you bring it down, and then it will equals to 3x over 2x plus 1 whole thing to the power of half, which becomes the square root. And by comparing, you can get that your k equals to 3. Okay, now part 2. Hence, evaluate the integral. Once again, firstly, you realize that it's impossible to directly integrate this integral because we can't use quotient rule. Secondly, you will notice that your integral looks similar to the answer that we've gotten. That's your two telltale signs that you should be using your Mr. A, Mr. B method. Once again, identify your Mr. A as the original equation that you had to differentiate, and your Mr. B as your differentiated answer. And then recall that integrating your Mr. B will give you back your Mr. A. And from then on, you can manipulate your Mr. B to look like the integral given in the question. So the only difference between your Mr. B and the integral is that your Mr. B is 3x while your integral is 7x. You can manipulate it by firstly dividing 3 on both sides. So from here, you just add a 1/3 on both sides. Then you realize that this cancels out, and you'll be left with x over 2x plus 1 dx equals to 1/3 x minus 1 square root 2x plus 1 plus c. And then in order to get your 7x, you will just multiply both sides by 7. So you multiply this side by 7 and multiply the other side by 7. That's why this will be your final answer. Our next example. Okay, now let's do our differentiation first. Using our product rule again, you eventually end up with minus x sine x plus cosine x. Now we need to find the integral of 2x sine x dx. So once again, your telltale signs is that you cannot start integrating from what the question gave you because we can't apply product rule in integration. Therefore, now we have to use the Mr. A, Mr. B method, whereby you identify your Mr. A as the thing you had to differentiate in the first place, and your Mr. B as the differentiated answer. Then you will start with the integral of Mr. B equals to Mr. A. And then manipulate your Mr. B so that it ends up looking like what the question wants you to find. In this case, this will involve splitting up our integral, which means that you split this up into minus x sine x dx plus integral of cosine x dx equals to x cosine x plus c. And then from here, you will take out the negative sign from your x sine x. Just like now, you have two different integrals. Afterwards, we are only focusing on the integral of x sine x because it looks the most similar to the integral that we require in our question. That's why we will be shifting the cosine x over to the right hand side. That's how you get this right hand side over here. Afterwards, you can integrate your cosine x on the right hand side because it's just a simple integration of trigo to form your sine x. Then we'll manipulate our left hand side to look more similar to 2x sine x, which is what we actually need. Therefore, we can multiply both sides by -2. And that's how we end up with the -2 in front here and our final answer. Now, next example. Show that differentiator of ln x over x equals to 1 minus ln x over x squared. Hence, find the integral of ln x over x squared. So firstly, we'll do our differentiation. Can we represent this as x minus 1 and ln x? Then we'll use our product rule from there, and then you should be able to show your answer. Once again, we are applying Mr. A, Mr. B rule. We'll identify our Mr. A as the original expression we had to differentiate, and our Mr. B as our differentiated answer. So starting off with the integral of Mr. B, the integrator of Mr. B gives us Mr. A. You will realize that your Mr. B is somewhat similar to what the question wants you to find. However, it's only on this side of Mr. B. So now we'll have to split the fraction on the left hand side. You can split it into these two fractions because they share a common denominator. And afterwards, we can further split this into two different integrals. Then since you're only interested in this highlighted one in yellow, we will shift the other one to the right hand side. Please note that there's an error here and there should not be an integral sign in front of ln x over x. Now from here, we can just do our direct integration. And then we'll get our final answer. Next question, we have the equation of a curve, and once again we have to differentiate it first. To differentiate, we will apply product rule, and after you use your product rule, we will, as mentioned previously, factorize out the smaller power. So in this case, negative half is the smaller power. Then we'll end up with x minus 3 plus 2x plus 1 inside the brackets. Simplify it to get 3x minus 2. We'll bring down this negative power to form 3x minus 2 over 2x plus 1 to the power of half, which can be re-represented into a square root. Now second part, use your result from part A to evaluate x over square root 2x plus 1 dx. Using our Mr. A and Mr. B method again, we will identify our Mr. A, which is what we had to differentiate at start, and our Mr. B, our differentiated answer. Then we'll start off by applying the concept of the integrator of Mr. B will give us our Mr. A. After that, we will want to manipulate our Mr. B into the integral we actually need from the question. If you notice, what we want from the question is actually only similar to this part of our Mr. B. Therefore, we will be required to split up the fraction in order to isolate our 3x over square root 2x plus 1. So this fraction will be split into two different fractions and then further split into two different integrals. We will only want to focus on the highlighted in yellow one. Therefore, we will shift this to the right hand side. Now let's simplify it first before we do our integration. We'll take out the 2 because it's a constant, and then bring up the denominator by making the power negative half. Then we can directly apply our reverse chain rule. Simplifying it, you will get this. Our final step will be to manipulate our Mr. B so that it looks like the integral we need in our question. It will be we can do that by simply dividing both sides by 3. Because we just want to make 3x into just x. Therefore, this will be our final answer.